All right. So number 4, create a Lineweaver-Burk plot from the table above using any 2 points. Calculate the Km and Vmax. So these are my 2 points I picked, the P5 and P6, and go from there. So the 1 over S is going to be our x-axis. Mark this. This is going to be the y-axis. Right, so the sorry, the Lineweaver-Burk equation is in the form of y equals mx plus b. So it's going to be 1 over b km over b max times 1 over s plus 1 over v max. Right, so it's the same as y equals mx plus b. All right. With that being said, since we already have the x's and y's up here, then we can actually solve for m, which is our slope. So as we learned back in algebra, m equals y2 minus y1 over x2 minus x1. So if we just put these in, y2 minus y1 over x2 minus x1, we're going to have 3.20 times 7 minus 1.70 times, what just happened? Sorry, computer did something weird. 1.70 times 10 to the 7. Right, that's going to be 1.50 times 10 to the 7. Right. All of this is going to be over the x2 minus x1, so it's 5.00 times 10 to the 4 minus 2.50 times 10 to the 4. Right, so that puts this over 2.50 times 10 to the 4, which will give you an m of 600. Okay, gonna hold on to that. All right, so now we have our slope. We can get our we need to solve for b. So by plugging them in, so we'll use 1.70 for our y, for y equals mx plus b. So 1.70 times 10 to the 7 equals our m, which was 600, times our x, which is 2.50 times 10 to the 4 plus b. All right, so solving for b, we're going to do this first, and it's going to be 1.50 times 10 to the 7, and we'll just bring everything else down. 1.70 times 10 to the 7. So we're going to subtract the 1.50 times 10 to the 7 from both sides. 1.50 times 10 to the 7 is going to leave us with a b of 2.0 times 10 to the 6th. So we're going to save this. Now I have our b. All right, so now we can solve for Vmax by just getting the reciprocal of b. So if we do, I'll do it up here, 1 over our b, which is 2.0 times 10 to the 6th, we get 5.00 times 10 to the negative 7, which is our Vmax. So that is one of our answers right here. All right, then we can solve for Km. So to solve for Km, we're going to take, okay, so we know that the slope equals Km over Vmax. So if you want to find Km, we just take the slope times Vmax. So we're going to take our 600, that was our slope, and just multiply it by our Vmax, which was 5.00 times 10 to the negative 7, which equals 3.00 times 10 to the negative 4, and that is Km. So now we have our Km and our Vmax. And if you wanted to double check your slope for the 600, you could do Km over Vmax, and you'll still get the same answer. It should be 600. Okay, so now we have our Km, our Vmax, and we just need to plot it. So let's see what the easiest way to do this would be, or you can see. Let's do this. All right, 1, 2, 3, 4, 5. A little bit too big. It's okay. And we'll do 1, 2, 3. All right. So this is going to be your 0. This is going to be your 1 times 10 to the 4. All these numbers are so big, we're just going to have to do it this way. 10 to the 4. 3 times 10 to the 4. 4 times 10 to the 4. And 5 and 6 times 10 to the 4. I'm getting a little crazy. Right, so then this is just going to be our 1.0, 2.0, 3.0, and 4.0. Right, and of course your y-axis, like I said before, is going to be your 1 over v. So 1 over v. So this is our 1 over s. And we'll do okay. So our x and y, y'all know we're going to go, so 2.5 is your x, we're going to go over about 2.5 and then up to our 1.7-ish, somewhere right here. Right? And then for our other one, we're going to go over to the 5 and then up, what was it, 3, up 3.2, so it's going to be like somewhere pretty low. Right? And I don't have a ruler, but we're going to try and mark this as good as I can with the Sharpie. Alright. Looks good. This would be your plot, your Lineweaver-Burk plot with our Vmax and Km solved.